So in today's lecture I will talk about two body scattering in the center of mass frame. So consider two particles. This is one particle A and there is another particle B. Both are approaching each other and at this point they interact, and then this particle goes in this way, one particle, and another will go this way, right? So it's A particle and B particle. These are the incident particle. And let its momentum will be P and its momentum will be P prime, minus P, negative of this, and the particle C having the momentum P prime and the D particle having the momentum minus P prime, and say it is the direction of the incident particle and this is the scattered particle. So with the incident particle it makes an angle theta, and here this angle will be 180 minus theta, right? This is the diagram which we have to keep in mind. So now for momenta of the incident and the scattered particle is given where? Now for momenta of the given particles is given as, so it's PA for moment of a particle, it is represented as P iota EA. Let us call it as equation A, and PB is equal to minus P iota EB. It's equation number 2. PC is equal to P prime iota EC, and PD will be equal to P prime with negative sign iota ED. So this is the four momenta of the particles. So now let us define S. So now S is equal to, as we have discussed in the earlier lecture, S is a Mandelstam variable and it is defined as negative of PA plus PB whole square, or it may be defined as PC plus PD whole square. So let us put their values. So let us elaborate this part. So it will be P comma iota EA plus minus P comma iota EB, it's whole square, negative sign, and this P will cancel out with it, so it will remain with the iota EA plus iota EB, its whole square with negative sign, and it is minus iota square EA square plus iota square EB square plus 2 iota EA into iota EB, right? So it can be written as, because this will become minus, this is also minus, so it is minus and minus EA square minus EB square minus 2 EA and EB, because this iota and this iota will be iota square and iota square will be negative, right? So now this minus makes everything will be positive, so that means S comes out to be E square plus EB square plus 2EA EB. It can be written as EA plus EB whole square, and similarly we can also prove that it is equal to EC plus ED whole square. So let us call it as equation number 5. Now T can also be simplified. For T, what do I do? T is equal to MA square plus MC square plus 2PAPC, as we have derived in the earlier lecture, and it can be written as MA square plus MC square plus 2P comma iota EA, and it's P prime iota EC, and this is like a dot product, right? So how this can be modified? This is MA square MB square, sorry, not MB but it's MC square plus 2P dot P prime minus, because this iota and this iota will be iota square, so it is minus EA dot EC. It's like a dot product, right? So it is MA square plus MC square minus 2EA EC plus 2P vector P prime vector and cos of theta, because theta is the angle between P and the P prime, right? So here theta, angle between P and P prime, right? So now let us reconsider, call it as equation number 6. So T is equal to this one. Now again reconsider S. So if I reconsider S is equal to PA plus PB whole square, or it can be written as EA plus EB whole square. Since we know that MA square is equal to EA square minus P square, right? Because as we know that this in the earlier lecture we have write down this expression, so using this I can write down it in this way. So MA square is equal to EA square minus P square, and similarly MB square can be written as EB square minus P, because the momentum will be minus P for the second particle, right? So this can be simply written as B square minus P square. So therefore I can write down it as MA square minus MB square. If I take their difference, then this P, this will cancel out with this part. If we take their this will cancel out, these two parts will cancel out. So therefore this is equal to means EA square minus P mod square minus EB square minus P mod square. This will cancel out with it, so it is EA square minus EB square, right? And it modifies to EA minus EB and EA plus EB, right? So therefore from here MA square minus MB square will be here. If I consider this, then from here I can write down EA minus EB. EA minus EB is equal to MA square minus MB square divided by EA plus EB. And as we have evaluated here, so from here I can write down EA plus EB comes out to be root S. So if I use this here, then EA minus EB, it can be written as MA square minus MB square divided by root S. Let us call this as equation number 7, and let me rewrite down this part. So if from here EA plus EB, it can be written as root of S, and let us call it as equation number 8. So now let us apply that 7 plus 8. So if I add these two, this EB will cancel out, so twice of EA, it is equal to MA square minus MB square over root S plus root S. And if I apply 8 minus 7, then EA will cancel out, so, and it is twice of EB comes out to be there, and twice of EB will be equal to root S minus MA square minus MB square upon root S. So let me simplify this part, and the LCM will be root S. It is MA square minus MB square, it will become S, right? So it is twice of EA. So EA can be written as MA square minus MB square plus S over 2 root S. Let us call it as equation number 9. And from here I can write down EB is equal to S minus MA square minus MB square over root S. So from here I can write down EB is equal to S, let us bring it here, so it is MB square minus MA square divided by root S. 2 will be there, right? This is equation number 10. Similarly, we can find out I can write down EC is equal to S plus MC square minus MD square over root S, and ED can be written as S plus MD square minus MC square divided by twice of root S. So 2 will also be there. It's selection number 12. So let us now calculate the scattering angle. So let us now calculate scattering angle. So as we know that PA PC, because it is the angle between A and C, so it is PA dot PC. It can be written as P vector iota EA dot P prime iota EC and it is P dot P prime plus iota square EA into EC. So it is P prime cos of theta its prime minus EA EC. So PA PC is equal to this one. So now PP cos theta can be written as EA EC plus PA PC. So therefore cos of theta can be written as EA EC plus PA PC whole upon PP prime. So in the earlier lecture we have derived that that 2PA PC is equal to T minus MA square minus MC square. So PA PC can be written as T minus MA square minus MC square whole upon 2. This is equation number 13 and this is equation number 14. Since PA square, again let us come to this one, as we know that PA square is equal to EA square minus MA square, and as we know that EA square means EA is equal to S plus MA minus MB as we have derived here. So its square divided by 2 root S, it is the value of EA and EA square, so that means its whole square minus MA square. So thus I can write down this as S plus MA square minus MB square whole square, and taking LCM, taking square and then taking its LCM, so it is 4S minus 2, sorry, it is the 4S will goes to here MA square, right? Now this part, this numerator part, this part simplifies to it is S square MA raised to power 4 MB raised to power 4 minus 2SMA square minus 2S MB square minus 2MA square MB square, and this is like lambda xyz, and this is equal to x square plus y square plus z square minus 2xy minus 2yz minus 2zx, and this is known as Galen function. This is known as Galen function, a triangle function. This is triangle function or Galen function. Right. So that means this part, if we simplify it, then it simplifies to this one. If you open this square, and it will be like this, right? So that means this can be written as 1 by 4s lambda s m a square mb square, right? That means this x is s, y is ma square, and z is mb square, right? So therefore it is equal to this one. So from here I can calculate p square. So that means p a in this case is p, so that means this can be written as, because we have to take its square root, or I can say that it is p square. Yeah, p square is equal to 1 by 4 s m a square mb square lambda. So I can write down here p is equal to square root of lambda s m a square mb square and whole divided by 2 root s. Similarly, I can write down p prime mod square is equal to 1 by 4 s m a square mc, it is okay, it is c and the d, mc square md square, right? So I can write down that it is p prime is equal to 1 by 2 root s, sorry, yeah, it is lambda s mc square md square under the root upon 2 root s, right? So let me call this as equation number 15 and equation number 16. So now using equation 9, 11, 14, 15 and 16, in equation 13, what we are getting? We are getting that cos theta is equal to EA EC minus PA PC divided by this P prime. So this will become it is S plus MA square, S plus MA square minus MB square over 2 root S into S plus MC square MD square over 2 root S plus T minus MA square minus MC square over 2 and whole upon it is lambda S comma MA square mb square whole under the root and whole upon 2 root s, and it is lambda s mc square md square whole under the root and whole upon 2 root s. So let us take their LCM. So LCM will be in the numerator, it is 4s, and in the denominator it will be 4s. So it can be written as four s, and it's again four s, right? And it is s plus ma square minus mb square s plus mc square minus md square, and it is plus, so it is 2s, it is 2s t minus ma square minus mc square and whole upon, and in the denominator they will remain as it is. So lambda s ma square mb square whole under the root, it is lambda s mc square md square, right? So this is it. So this 4s will cancel out with it, and this will be equal to, now it is s plus ma square, sorry, it is minus, right, minus mb square s plus mc square md square plus 2s t minus ma square minus mc square whole upon s ma square mb square under the root, it is lambda s mc square md square under the root. So this part, it simplifies to, so therefore cos theta, it can be written as s t minus u plus ma square minus mb square into mc square md square whole upon lambda s ma square mb square under the root, and under the root lambda s mc square and md square under the root, right? That's what we are getting here. So this is the equation number 17. Let us now check how this part is equal to this part. Let me check it out. So for this, let us do a little calculation. So we are having that it is s plus ma square minus mb square, it is s plus mc square minus md square plus 2st minus ma square minus mc square. So let us simplify it. So it will be s into s plus mc square plus md square plus ma square s plus mc square md square minus mb square s plus mc square minus md square plus 2st T minus ma square minus mc square, right? So let us simplify. It is s square plus smc square minus smd square plus sma square plus ma square mc square plus ma square md square. It is minus s mb square minus s mb square mc square plus mb square md square plus 2st minus 2sma square minus 2smc square, right? So let us first of all put all s terms together. So it is s smc. Is there more term smc? No. And smd is also not there, right? And there is sma square, 2sma square. So it is plus, it is minus, so it will we will remain only with the one term, and this is plus and this is minus, so both can be put together, and smb square will be there only one term, right? So what I can do, I can write down this as s square minus smc square, these two terms when they put together, and minus smd square and then sma square and this one, so it is minus sma square, right? And another term will be smb square, so it is minus smb square. Then plus 2st will also be there, and remaining terms are plus ma square mc square minus ma square md square minus mb square mc square plus mb square md square. So if I take s common, inside it will be s minus mc square md square ma square mb square, and if I take minus, because every term will be negative, so inside it will be positive sign, plus 2t, and plus ma square can be taken outside to mc square minus md square, and then minus mb square can be taken outside from these two terms, so inside it will be mc square and here it is md square. So they can be put together as a factor. So therefore this is equal to, and mc square md square ma, it is s plus t plus u, so here it is s into s minus s plus t plus u plus 2t, so this s will cancel out with it and this will cancel this one t because it is negative, so it is t minus u, and here it is ma square minus mb square into mc square into md square. So here it is t plus u, t minus u inside, and outside it is s, and it is ma square minus mb square into mc square minus md square. So hence this part will also be proved like this. So you can use this result directly. Now let us consider the case of elastic scattering. Special case, the case of elastic scattering. So this is the relationship which we know. Now for the case of elastic scattering, for elastic scattering. A is equivalent to C, B is equivalent to D, and EC is equal to EA, and ED is equal to EB, and MA is equal to MC, and MB is equal to MC, and momentum will also be equal. So now T is equal to 2PA PC plus MA square plus MC square as we know it. So it is MA square MC square plus 2P iota EA, their values, and then dot product with P prime comma iota EC, right? So it is MA square plus MC square plus 2P dot P prime, it is minus twice of EA and EC, it is MA square MC square plus 2P P prime cos of theta minus 2EA EC. So EA and EC are equal, and this is also equal. So how do I write down it as? This is equal to twice of MA square plus twice of P mod square cos of theta 2EA square. So that means twice of MA square minus EA square plus 2P square cos of theta, and this is equal to T, and this is equivalent to minus P square. So that means this T can be written as minus 2P mod square plus 2P mod square cos of theta. So it is T is equal to minus 2P, it is 1 minus cos of theta. So I can write down that T over 2 minus P mod square is equal to 1 minus cos theta. So from here I can write down cos theta is equal to 1 plus T upon 2 plus P mod square. So this is expression for cos theta. This is expression for cos theta. Let us call it as equation number 18. And there are another ways to write down it, and it can also be written as that T is equal to T is equal to minus 2 P mod square 1 minus cos theta, and 1 minus cos theta can be written as 2 sine square theta by 2. So therefore I can write down this T as minus 4P mod square sine square theta by 2. Similarly, we can prove that U is equal to minus 4P mod square cos square theta by 2. So this is all about the scattering angle, and we have talked here scattering angle for the center of mass frame of reference, right? That's all for this lecture, and in the next lecture I will talk about scattering angle in terms of lavatory frame of reference. So that's all.